get started. So I would like to welcome you guys to a WebEdge webinar series. Today's agenda is to discuss various deployment options that are available in Kubernetes. And topics-wise, we will basically discuss what is containerization, how you can implement containerization by using Docker. We will see how we can create a file called Docker file that lets you create Docker images because you need to create your Docker images first before you can create your containers. And then we will see how we can deploy our images to our Kubernetes cluster. I'll give you an overview of what exactly a Kubernetes cluster is, and then we will see how to deploy our application to a Kubernetes cluster. And that's where we will discuss various options or deployment options. We have quite a few, and so we need to know when exactly to use what approach and so on. And one small note here, we will only focus on the deployment, not on update. Like if you already have any existing deployment, usually you'll want to update your existing deployments. So that is a different area. We do have detailed courses available where we talk about the update options. For example, we get to use blue-green deployment, we get to use canary releases, we get to use the rollout technique. That is the default technique, basically. So basically, updating an existing application, that is a different area, whereas deployment means how you can deploy your application the first time around, and after that, sure, you'll want to maintain the application as well. And if you have time, I'll try to give you a brief overview of various update options as well, but the main scope of this webinar is just to focus on the deployment options. And then we will see how we can run commands in a container that could be running in sort of a standalone manner, like you do not have Kubernetes. Maybe you just have your Docker uh, service installed and you just have created container, and now you want to run some commands in a container. And I'll also talk about how to run commands in a container, or to be more precise, a container that is deployed to our Kubernetes cluster. So basically, after deployment or post deployment, you can run various commands to check the status of your containers, or see what files are there, or what environment variables are available to your container and so on. And then I'll give you a brief overview of multi-container pod concept as well. So basically, we have quite a few things to cover in this webinar. So first of all, let's start off with Docker. So before I continue, if you guys could please give me a raise of hands. So how many guys have used Docker or Kubernetes? So how many of you are already using Docker or Kubernetes at work? So in this webinar software, if you guys could please raise your hand. Okay, so very few people. So in that case, I'll give you overview of Docker first. What exactly Docker is, what is containerization, why we should create containers, and then we will see how to deploy our Docker images to our Kubernetes cluster. So Docker is an open source technology, and it allows us to create uh, images. So just like we usually have virtual machines, they also have images. So likewise, we get to create Docker-based images. Now, question is, what's the point? Why create Docker-based images? Why not use the VM-based images? The answer is that Docker-based images are very, very lightweight compared to the full-blown virtual machine-based images. Because a typical VM will contain the operating system, and then you'll be able to deploy your application and so on. So for example, in a typical VM, you first of all have to make sure you have some sort of hardware available to you. This is, let's say, your actual machine, and then on top of the machine, you will have to install some operating system, like you will have Windows or Linux or Mac OS, etc., and so on. And then you'll be able to install some virtualization software, such as VMware, Hyper-V, VirtualBox, and so on. And then you get to create multiple VMs. So each VM will again have its own operating system. So you need to install the operating system in each VM from scratch. And that is where we have too much extra overhead. So since you are duplicating your binaries, you already have some operating system available at your local machine or on your local machine. So why are you reinstalling the operating system again in each and every virtual machine? You're duplicating your storage requirement. So in case if you need a Windows-based machine or a virtual machine here, maybe you want to use it as a database server or maybe as a web server or something like that. Why are you reinstalling the same Windows operating system? It could be a different operating system, but an OS is an OS. It just offers some services like communicating with the hardware, stuff like that, and so on. So basically, in case of virtualization, this is one of the major drawbacks that you need to reinstall the operating system in each and every VM. And another drawback to using the traditional VMs is that you need to allocate resources. So you have to say that your VM should have, let's say, a certain number of CPUs or cores assigned to it. Like, let's say, 2 cores will be allocated to this one. You also need to specify how much RAM you want to dedicate. Like, you could say, I want to allocate 4 GB of RAM to this particular VM. So basically, you have to dedicate your physical resources to each and every VM. This is the major drawback. And it's not that VMs are bad. You should ditch or get rid of VMs altogether. No, VMs, they have their separate purpose. So a VM should be used as your infrastructure, not for your software deployment. So for software deployment, you can still use a VM, and on top of a VM, you can use Docker. So it's up to you. You can still have a VM in place and just install Docker as a service, or you can definitely say that we do not even have any virtualization software. We just have our hardware, the way we have on the left-hand side. So you can have your hardware, you can have your host machine level operating system, like it could be a Windows, it could be a Mac OS, it could be any distribution of Linux as well, and so on. And then you can choose to install Docker directly on top of your regular machine. And in case of Docker, you'll be able to create Docker images that I'll show you in detail in just a bit. And you'll be able to create containers based on those images. So essentially, each container, so containerization, each container is independent of the operating system in a sense that there will be no extra copy of the OS in each and every container at all. So OS wise, all these containers will basically rely on this Docker service. And the Docker service will basically make sure that it connects to your host level operating system, and whatever services are needed by your containers, they are made available to the containers. So now you can choose to have a container where you could have your maybe a web server, you could have a container where you could have something else and so on. But actually, we don't even use uh, a separate dedicated container for a web server, a separate dedicated container for database server. Instead, we use something called microservices architecture. So sure, you can still have a web server, you can have a database server and so on, but typically we try to follow the microservices architecture these days. And microservices basically means every container should contain a specific service that fulfills part of the overall problem. So let me say that again. So it basically lets you deploy multiple small services, and each service is responsible for itself. So rather than deploying the entire web application, the entire collection of APIs or the RESTful APIs or the backend APIs to the same image or to the same container, we split it into multiple small containers. So containerization basically is independent of the OS. Like it doesn't even care for what OS you have, and I'll discuss that in more detail in just a bit. But in short, all these containerized applications will rely on this Docker service, and the Docker service will talk to the operating system and provide all the services. Um, let's cover this in more detail. So Docker is a containerization based solution, and it lets you create images um, You can think of image as a packaging solution or a packaging technique. You get to package your application so that you can later on deploy it. And all Docker-based containers they are very, very lightweight compared to VMs because there's no extra overhead of the operating system, and you do not need to dedicate any amount of RAM or CPUs to your containers. You can still do that if you want, but you don't need to. And before we see containerization in more detail, let's talk about where you can run Docker. So Docker, that is a containerization solution, can be used anywhere, literally anywhere. And this is one of the major benefits you get with Docker. It makes your application portable. So you use the exact same technique to deploy your application uh, that you can use in your on-prem environment or on any cloud platform as well. So you can use Docker on Linux, on a Mac OS, on a Windows, uh, and you can also choose to use it in your cloud-based platforms such as Microsoft Azure, Amazon AWS, Google GCP, Alibaba, name it. So pretty much every major uh, vendor or cloud platform supports the same containerization concept. So it makes your application portable. And this basically means you're future proofing your application. So you can have a peace of mind that the way you're developing your application in your on-prem environment, it will work on pretty much every platform. It's basically a more modern way of making your application portable. So portable, what exactly does that mean? Yes, we get the picture that you can use it on any operating system, but how exactly it's becoming portable? So it's becoming portable because you get to create containers eventually, and containers will be based on your custom Docker images. Now we need to understand this containerization concept in more detail. So containerization basically means you get to package everything that's needed to run your application. So what does that mean? So typically you need several components to make your application work. Let's, as a case study, talk about WordPress. So WordPress is a blogging solution. Everyone is aware of WordPress. So WordPress, it relies on several components. You need uh, MySQL or some other database server so you can store all your posts, etc. and so on. You need Apache Web Server because WordPress is essentially a web-based solution. So you need Apache Web Server. You need to install PHP plugin uh, on top of your Apache Web Server, and then you get to install the WordPress itself. So there are several components. If you think in terms of the traditional setup, you would say, okay, we should have a dedicated VM where we should have, let's say, MySQL database server. Let's have another dedicated machine, and let's use it as a web server. Let's install PHP on top of it, and then install WordPress on top of it. Sure, you can do it like this if you use virtualization. But mm, in that case, you're using the monolithic architecture. You're no longer splitting your app or sort of using the containerization sort of concept and so on. So basically, when you use this containerization concept, what you can do is you can still choose to create multiple separate containers. Or to keep things very simple, let's start off with the simple scenario before we see the microservices sort of implementation. So what you can do is you can containerize just the software. So the OS, we don't even care for the OS at all. So the OS will be outside of all this stuff. And on top of the OS, you will have Docker service installed. And the Docker service will let you create your custom Docker images. And I'll show you that in just a bit. I'll first of all start off with this WordPress example and show you how to run it as a container. So basically, once you have your Docker, you can choose to use WordPress as a container that already has MySQL, Apache Web Server, PHP, WordPress. All the dependencies that are needed to run your application can be contained inside a container. And I'll show you that in just a bit. And later on, we will see that yes, you can definitely split it into multiple small containers if you want. But let's start off with this particular concept that containerization means encapsulate every possible dependency that's needed to run your application. So just the software level dependencies. We don't care for the OS at all. So due to containerization, your overall size will be very small because it doesn't contain any OS uh, sort of headache at all, or overhead at all. And it only contains just the files, just the binaries that are needed to run your application. And later on, I'll talk about custom application sort of scenario as well, where you maybe have a Java-based application or a .NET application. Even in that case, if you have, let's say, a custom Java application, typically your Java application will have .jar or .var sort of files. And you can say that I want to containerize my application, and it means your binaries and also the dependencies such as JDK or JRE. You want to bundle it up as part of your overall application. So you can basically encapsulate everything that's needed to run your application. Same goes for your, let's say, .NET applications. You can have your, let's say, all your files, including your .dll files, and let's say .NET or .NET Core runtime environment bundled up inside a container. So initially, you'll have to create a Docker image, and then you'll be able to create a container based on that image and so on. So basically, this is what that makes your application portable, because this layer will run regardless of what OS you have. Whether you have a Windows or a Linux distribution or a Mac OS, no one cares as long as you have this Docker service up and running. So Docker will make sure that you're able to run your application anywhere because of this containerization concept that bundles up all the dependencies that are needed to run your application along with your binaries that you want to deploy. So there are no file system or OS level file system level dependencies anymore. There's no dependency on your operating system level registry that we have in case of a Windows-based OS and so on. So basically, containerization means we want to make our application portable. And like I pointed out, you can bundle up your jar, var, DLL files along with all the runtime environments and so on. And typically, every container, it has to be based on some image. And I'll talk about the process in detail in just a bit. But typically, we have to make sure we use some base image. Just like virtual machines, they are based on some images. Likewise, all the containers, they are based on some images. So you have to start off with some image. And then after that, you can specify your container specific files that you want to make a part of your containers along with all the runtimes, dependencies, and so on. Let's cover this in more detail. So next, keeping in mind that containerization essentially bundles up all the dependencies like JRE, .NET runtime environment. Uh, Even if you are using, let's say, JBoss, WebLogic, WebSphere, sure, that is your dependency as well. So whatever you can think of as a dependency that you need to run your application, you bundle it up along with your binaries. And that will basically become your Docker image. And then later on, you can create your containers based on that. So uh, typically, to create a Docker image, you get to create a script or a file named Docker file. So say we have a simple sales application, or actually in my case, I have a couple of services, small applications. I have a simple restaurant sort of scenario. So I have a restaurant web, and I also have a restaurant API, or you can call it the backend. So I have a couple of applications basically. And before I continue with the technical details, so basically assume that we have some database. And it can be any type of database. We don't even care. It could be SQL Server, Oracle, MySQL, and so on. And way over here, we have some end user who wants to access our application. So say we have some web server, and there we have our front end, the web front end deployed there. So restaurant web is the web front end. And the web front end, typically we do not let the front end application directly connect to the database. Even if you are using, let's say, Java, etc., and so on, typically it's a bad practice to let a web front end directly connect to your database server. And especially when you have the modern front end applications such as Angular, Bootstrap, or sorry, React, Backbone, sort of, or Vue.js sort of applications, or Polymer web components, and so on, these cannot even connect to the database server at all. So typically, you'll want to have a web front end, and typically we also make sure that we have a backend where we have a bunch of RESTful APIs. So representational state transfer sort of APIs. These are the RESTful APIs, the backend APIs. Or you can use web services if you want. Otherwise, these days we also have gRPC option as well, and so on. So typically, this REST API will connect to this particular database, and the web front end will basically send a request to the web to the REST API, and it will basically receive the data from the database. It will be forwarded back to the client application, and then it will be delivered to the web browser that the end user is using, and so on. So basically, keeping this in mind, that we have sort of three separate tiers. We have the web front end portion of the application. We have the backend API. I have a couple of applications, Restaurant Web and Restaurant API. They will both use Java. This one is using JDK with Gradle as the build engine, whereas this one is using JDK with Maven as the build engine. You can choose to use different technologies like .NET, PHP, Python. You can use whatever technology you want. But for now, I have these two applications. So containerization would mean bundling up JDK and our actual jar file or the WAR file that we need to deploy or need to run so that our web front end application can be up and running. Likewise, we have this restaurant API. It also has JDK as a dependency in this case. And in my scenario, I'm going to use Java with Spring Boot. So I'm using the Spring framework, or to be more precise, I'm using Spring Boot to make Spring framework easier and faster to set up, etc., and so on. So basically, all the dependencies like JDK and your application will be bundled up. And how do we create a containerization-based solution? So you have to make sure that if we have two separate projects, like in this case, I do have two separate projects, I'm going to make sure that we create a Docker image first. And to create a Docker image, we have to write a script. And the file name is typically named Docker file. You can change the file name to something else if you want, but in that case, you will have to use different arguments to create your Docker images. And I'll show you the syntax for this Docker file in just a bit. But when you run this Docker file, so each application that we have here, it needs to have its own separate Docker file. And when you run this Docker file, it will create a Docker image for us. And you can name the image whatever you want. And later on, you'll be able to use the exact same image and create multiple containers based on that. So an image is nothing but just a blueprint. It's a template. It's a collection of all the dependencies and your binaries that you eventually want to deploy later on. So we will end up having a Docker image, and later on you can choose to run as many container instances based on that as you want. So each container is nothing but just a running process based on your image. And unlike VMs, where there's a limit to how many VM instances you can run on a given machine, unlike VMs, In case of Docker, you'll be able to run insanely large number of uh, containers on the same machine, because it's a software-based containerization technique that doesn't sort of duplicate your storage requirement. Like, it doesn't have the OS requirement for each container, and likewise, you do not really have to dedicate RAM and CPUs to your uh, containers at all. Although you can limit the physical resources, but you don't need to. So likewise, your second application, like your backend application, when you create your Docker image by running a script called Dockerfile, again, you'll be able to create multiple Docker instances or container instances based on the same image. So keeping this in mind that you have to, first of all, create a script named Dockerfile to create your Docker image. Let's look at the sample code. I'll show you a demo in just a bit. So basically, here we have a sample script to create a Docker image. So whenever you want to create a custom Docker image, you end up using this from keyword to specify what's your base image. So for now, I want to make sure that since I do want to use Java as a dependency or JDK as a dependency, I want to use this as a base image. For now, just know that all these base images are initially hosted or available on a public repository or a registry called Docker Hub. We usually have to download some base image, and then after that, we get to customize that base image. So you can choose to have any base image, like your base image could be based on JDK, it could be based on .NET. Let me actually quickly show you the site as well. So let's say if I open up this hub.docker.com, you will notice that we have a bunch of images available here. So we have, let's say, OpenJDK, we have Spring Boot sort of images, we have Oracle images as well, we have pretty much everything is available here. Even WordPress is available here. So we already have a base image that already has WordPress pre-installed and so on. So basically, you need to use some base image, and initially it will be available on this Docker or hub.docker.com website. You need to download some base image, and then you can customize it. You do not need to have the internet connection in the production environment at all, or even in the dev environment. But initially, you do need to download some base image, and after that, you can totally disconnect from the internet and do the rest of the development and so on. And that is where in advanced cases, companies or organizations usually create their own local registry of these base images. So it is possible to create a local registry and have all the images located on the local machine or on some local server and so on. Okay, so you basically have to make sure you use some base image, and then you have the ability to run various commands and so on. And let me actually show you a practical example of this thing. So if you recall, I mentioned that I have that restaurant web sort of scenario. The restaurant web wise or a restaurant scenario wise, I have two services or two applications. I have the web front end and also a back end as well. So let me first of all show you a quick overview of the restaurant web front end application, or let's look at the back end first. If I go to my demos folder, here I have my restaurant API. This is my backend basically. So I'm using Java. I'm using Gradle. So those guys who use Java with Gradle, they will recognize the folder structure. I have Java source code available here. It's a regular Java project. There's nothing special about this thing at all. And very importantly, all you have to do here is you have to create a script called Dockerfile. And this Dockerfile is where we have all the code, like how to create a Docker image. So let me quickly show you this Docker file here. So this is the script that I've used to create my custom Docker image. We don't have time to go through all the details. We covered that in our full-blown courses. For now, know that the first section of this particular Docker file is responsible for building the application by using JDK10 along with Gradle. So Gradle will be used as a build engine that relies on JDK, and I'm going to perform the build operation. So Gradle boot jar, it will create my executable jar file that's based on my Java Spring Boot application and so on. And the second phase of this particular Docker file is responsible for creating our actual Docker image that contains our uh, all the binaries that we have built. So basically, the output of this particular stage number one, will be sent to stage number two, and we can see that it's basically copying all the files from stage number one. So my stage number one, I've aliased it as a builder. So I'm getting all the binaries from my first stage. And then I can use this particular Docker file specific keyword called entry point and run my jar file. So basically, when you run your jar file, it will start up its own built-in Tomcat/Jetty based application server, and the application will be up and running. Even if you're using, let's say Spring, or let's say JBoss, WebLogic, WebSphere, etc., and so on, you can still use the same Docker file-based approach with some changes so that you accommodate JBoss, WebLogic, WebSphere sort of features or changes and so on. So in short, for now, know that this particular Docker file is responsible for compiling the code and also creating a Docker image that contains my dependencies plus my binaries. So just the dependencies and the binaries will be available in my Docker image. And let me actually run this particular jar file, or sorry, the Docker file script, so I can show you what it looks like. So once you have your Docker file script in place, how do you run it? So to run your Docker files script so that it can create your final Docker image that contains all the dependencies along with your binaries, etc., and so on, you can use the Docker build command. So when you use Docker build with these arguments like -t along with your name that you want to assign to your Docker image, it will run your Docker file script that's located in the current folder. So the dot at the end means it will run the Docker file script that's located in the current folder. And once you have your Docker image built, later on you'll be able to deploy it to Kubernetes. So let's quickly run this particular script so that we can have our Docker image ready. Let me go to the folder where we have this particular example or demo. Okay, so let me make sure I'm in the right folder. Restaurant API, I'm going to build my backend application first. Here I can run this Docker build command. I can specify what name I want to assign to my custom Docker image that will contain nothing but just the backend API. And the dot at the end means it will run the Docker file script. So basically, it's now running stage number one that will utilize Gradle with the JDK to build my application. So it's building the application right now. And once the build operation is done, the next phase is to create a custom Docker image that should contain nothing but just the dependencies like JRE and or compiled application. So the first stage is compiling the application, or to be more precise, building the application. And this is where you can choose to run your unit tests, etc., as well, and so on. So it's still getting executed. So Gradle will take a bit of time. Eventually, our application will be built. And then stage two will make sure that the dependencies like JRE along with our binaries, they are bundled up in a single Docker image. And the same Docker image can run anywhere. It can run on a Mac OS, on a Windows-based machine, on a Linux-based distribution, on any cloud platform as well, and so on. So it's a portable way of packaging your applications. So if nothing else, just associate Docker with portability. that it's a packaging solution that makes your application portable, that runs everywhere. Okay, so it's almost done. And once the build operation is done, we'll end up having, or the second stage will execute. That will basically create our Docker image. And once we have these Docker images ready, I'll discuss Kubernetes, and we will discuss how we can deploy our application to our Kubernetes cluster. And we have various techniques there. Like you can use a simple command line based approach, or you can run some uh, manifest files like the YAML files and so on. Okay, so we are done with this process. We have our custom image available now. Let's verify that we have the image. And let me actually resize this a little bit so I can see it properly. Okay, so here we can use the Docker command, images, and I can just let it display all the Docker images. So we have a bunch of images here. Here you can go through this list. Eventually you'll see that we have this restaurant API custom Docker image that is only 147 megabytes in size. That is it. It's 147 megabytes in size. It contains our application and all the dependencies. And one more small note. Like I pointed out, Docker runs everywhere. You can have it installed on a Windows-based machine, on a Linux-based machine, on a Mac OS-based machine. So if you guys want to experiment with Docker on your personal machine, like if you have a Windows, make sure you have Windows 10 or Windows Server 2016 for the best experience. Otherwise, if you have any older version of Windows, then in that case, you will have to rely on the older version of Docker that is very slow. So ideally, you want to have Windows 10. Otherwise, if you have Linux or Mac OS, it will run there without any problem. Again, you'll want to make sure you have a newer version. So Docker wise, you can install something called Docker Desktop, and it's totally free of cost technology. So Docker Desktop. So search for Docker Desktop, install it, and actually it contains Kubernetes as well. So it's not just Docker, it also contains Kubernetes as well. So once you have it installed, if your service is up and running, it will show up here in your notification tray. Okay, so here we have built our first application, and we can see that we have our Docker image available for it. And to save time, I've already built my second image, restaurant web, and that is 124 megabytes in size. So we have both our Docker images available. And the size, this is what that makes it absolutely mind-boggling compared to, let's say, virtual machines. Because in case of VMs, typically you see sizes such as 10 GB, 15 GB, 20 GB, because they contain the OS, they contain extra free storage for the paging file, etc., and so on. Whereas here, Docker images are super small because they only contain the dependencies and or binaries. No OS is there at all. There is no dedication of any free space for the paging file, etc. at all, and so on. So basically, once we have these Docker images, these are portable. The same Docker images can run or can be used anywhere you want, as long as you have the Docker service there. And there's one more important component called Kubernetes. Although it is possible to run your Docker containers without using something called Kubernetes, but with Kubernetes, you will get several benefits. So before I talk about Kubernetes, let me quickly show you that it is technically possible to run your Docker image without using Kubernetes whatsoever, and your application will still work. And then I'll point out what is Kubernetes, how you deploy your application to Kubernetes, and what benefits you get with Kubernetes. So for Docker, let me quickly run my script here. That will basically let us access our application. Okay, so if I, let's say, run this particular command, let me go to my power shell here. Okay, so if you use this Docker container run command, it will let you start up your container instance. And apparently, I do not need to use a bunch of arguments like this one. And notice that it barely took a second or two to create a container instance. So it barely took just a second or two to create this container instance. Unlike VMs, that takes at least a minute or so for the OS to show you a message that it's loading the files, it's booting up, and then after that, it will basically run your actual application and so on. So unlike that, here, it barely took a second or two to run your container instance. So that is another benefit you get with Docker, containerization solution. So portability plus performance. So it's very, very fast to create your containers, to destroy your containers, to start them again, to shut them down or restart them and so on. It's very, very fast. And you can choose to test your application. I can use, let's say, just the curl or the command line tool, or I can also choose to look at my result here. So this is basically my backend API. And we can see that it's returning this JSON sort of data and so on. So later on, I'll show you the web front end as well. That will be fancy. It will have the user interface, etc., and so on. But for now, I've deployed my, I've started up a container instance of my backend API. So this backend API contains all the dependencies and my RESTful API that's needed to access a list of sort of sample, sort of dummy restaurants, etc., and so on. So although it is possible to run your container instances like this, and you can verify that your container instance is up and running, it's part of Docker. We have this container instance up and running, but typically we do not use it, use the containers like this. Instead, we deploy to Kubernetes. So let me first of all destroy this particular container. I'm going to use Docker stop and then specify the name of my container. It is restaurant API dash container. And let me delete the container as well. So it's very fast to start a container instance, stop it, destroy it, and you can later on recreate it as well and so on if you want. So although it is possible to start up individual container instances like this, but typically we combine Docker containers, or we combine this Docker technology with something called Kubernetes. So Kubernetes is a deployment platform where you get to deploy your Docker images in a more efficient manner that provides you with lots of benefits. So benefits wise, let me summarize the benefits. Load balancing. Typically in a real world scenario, we prefer having load balancing in place so that if there's too much load on a single instance, then the alternate instances should be available to us and they should uh, reduce the overall load on our system and so on. So basically you'll be able to create multiple Docker container instances by using Kubernetes, and load balancing will be provided to us because of Kubernetes. The Kubernetes is a deployment platform where you get to deploy your Docker images, and it will offer load balancing and also auto failover, so that if any container instance has crashed, then some alternate container instance should start offering the services to us and so on. And there shouldn't be any sort of downside, or we shouldn't have any downtime involved and so on. And in fact, it is not just auto failover. It's called self-healing instead. So self-healing means that if any instance has crashed, it's damaged, it's no longer up and running. Maybe there was some exception thrown. Maybe your database service crashed, maybe your web service crashed or something like that. Then self-healing means it will definitely redirect the traffic to your alternate instances, and whatever instance got damaged, it will actually replace it with another identical instance, so that uh, we can always have load balancing and we can always have a peace of mind that we don't have one less instance available to us. You will always have the same number of instances available to you that you have configured. So scalability, load balancing, self-healing, these are the major benefits you get with Kubernetes. And actually, these are just the tips of the iceberg. It's a huge technology. It contains lots of additional features as well and so on. But for now, we will just focus on this load balancing and self-healing sort of concept. And I'll show you this practically in just a bit. Now, if you have to deploy your application to Kubernetes, your Docker images, basically, you have various syntaxes. And each syntax has different pros and cons. So method number one is the easiest one, and that is known as the generator-based approach. So you can choose to use kubectl with the run argument, or you can choose to use kubectl with the create argument without specifying any YAML sort of manifest or sort of configuration file and so on. So this is the easiest approach. And I'll show you this practically in just a bit, along with the more sort of advanced technique as well. So if you use run or create, it's known as the generator-based approach. And even when you talk about, let's say, run and create, there's a difference. So run, kubectl run command, Kubernetes control, that's basically the command name that we use to interact with the Kubernetes cluster so we can deploy our application. So you can use the run argument, but its major drawback is that you cannot scale your application after deployment. It's not possible to say that I want to have load balancing available if you use this kubectl run option. So use this option only to quickly test your application, whether whatever Docker image you have, whether it will work properly on Kubernetes or not, and so on. If you still want to make your deployments easy enough, but you want to benefit from load balancing, scalability, self-healing, and so on, use the kubectl create argument-based technique. So kubectl create deployment. So overall, you get to use the same arguments, but when you use this create deployment-based technique, your deployment can be scaled out. And there'll be self-healing, there'll be auto failover, there'll be load balancing as well, and so on. So this is the easiest approach, but not the recommended approach. Use it mostly when you have to just quickly test your deployments. And the major drawback, even with this particular approach, is that it's not something that you can repeat. You have to run this command manually to perform your deployment, and then you also have to use a command called kubectl expose to expose your service so you can start accessing it. So in short, it's not a repeatable, it's not an automated way of deploying your application. If your entire infrastructure has been damaged, your machines have crashed, all of them, and you need to reinstall everything from scratch, you will have to run all these commands again from scratch to perform all the deployments and expose all the services so you can start accessing them and so on. So typically, this is not recommended in the production environment, but yes, it's the easiest approach. And let me quickly show you this approach before I show you the YAML file-based approach as well. So I'm going to use the same restaurant sort of scenario. I already have a couple of Docker images. One is for the backend API, and the second is for the web front end. And I'm going to deploy my application. And let me also show you the scalability aspect as well. So I'm going to use the kubectl create deployment based approach to deploy my backend first. So I'm going to run this particular script here. So this will basically deploy my backend API. And next, in order to make sure we are able to access the backend service, we need to make sure that the ports that we have assigned to our service, they should be exposed. So I'm using this kubectl expose deployment command to make sure that I should be able to access the service at port number 9001. And next, I can do the exact same thing with my second application or the web front end portion of the application that will talk to the backend API. So I'm going to use kubectl create deployment. My web front end is named restaurant web. And then I'm going to make sure that it has some environment variable assigned to it as well. Ignore the environment variable concept for now, but typically you'll want to make sure that you do not hard code certain values in your code. You always pass them as part of your environment variables. And let me expose this thing as well. Okay, so basically whatever I've done here by executing these commands will make sure that our service is now accessible and our application is hosted on Kubernetes. So if I use the port number 9000, this is for my web front end. Okay, so here we can see our front end application. And all this data is actually received from our backend API. So the backend API is talking to my database, and the backend API is basically sending the data to my web front end. So initially, my web front end will send a request to my backend API, and the backend API will connect to some database, and it will receive the data from the database and then return it to my application in JSON format, JavaScript object notation format. And now we are displaying it in fancy manner like this and so on. So basically, so far we have just seen how to deploy our application to our Kubernetes cluster. But the question is, what's the point? What's the benefit of using Kubernetes? You could have done that without Kubernetes as well, even with VMs and so on. So what's the point? What's the sales pitch here so we can really get impressed by this Kubernetes technology? So for that, I'm going to talk about scalability. So scalability means have multiple identical replicas. So let's assume that we are expecting too much load on our front end. So too many users will be accessing the application at the same time. So I can scale out my deployment. I can say that I want to have 3 replicas or more than 3. First of all, let me find out how many instances we have here. So get pods. So pod is a term used in Kubernetes. That means it's sort of an instance, basically. So we have exactly one instance of our API and of our web front end as well. So we have exactly one instance of both the services at this point. So it cannot handle too much load at this point. So to scale it out, I'm choosing to scale out just my web front end. So I want to have 3 instances. And even though I do not have a very high-end machine here, I can easily scale it out like this. It's done in just a matter of a few seconds. Now we have 3 identical instances of the web front end. So we have 3 instances. So there's load balancing now. There is auto failover as well. And I'll show you both the load balancing and the auto failover practically in just a bit. And in fact, you can choose to have, let's say, 10 instances. Even though I have a fairly sort of medium level hardware configuration on my working machine or this particular machine that I'm using, but still I can have 10 instances of my web front end running on the same system. And if I use get pods, they're all up and running already. So there are 10 instances, and each instance will be capable of providing load balancing and auto failover, etc. and so on. And let me scale it down back to 3 for now. So we have scaled it down this time around. If I get the parts list, so it's terminating the extra parts that are no longer required. It will scale it down to just 3 for the web front end. Now to see load balancing in place, like it's working, notice that every deployment or every instance has a unique ID assigned to it. And I'm displaying the ID here on my web front end. This is my custom logic I've used in my Java application to display what's the ID of the pod or the instance that's fulfilling this request. So here, if I, let's say, typically it will be faster to show in or from Chrome. Let me go here. Okay, so notice that this is the ID of my pod that's fulfilling the request. So if I keep on refreshing this page repeatedly, if I keep on bombarding my web front end by sending requests too many times, you will notice that the ID will eventually change. So it's still loading the page, and we can see that it's now WC, whatever the ID of the pod is or the instances. Now it's N9. So basically, we have 3 pods. We have 3 instances of our web front end, and there's load balancing. So basically, each time when Kubernetes detects that there's too much load on a specific instance, it will forward the request to some other instance automatically and so on. So load balancing is available here. And to show auto failover and self-healing, I'm going to go crazy and I'll use kubectl. I'm going to delete all the instances, container instances, manually, just to simulate some disaster. So I'm saying delete all the pods, delete all the container instances that are running on Kubernetes. Even though I'm deleting them, but Kubernetes will automatically start them again. It will replace the damaged instances with the new up and running fully functional instances automatically. So if I, let's say, get the parts list again, get parts, you will notice that we still have the exact same number of parts, but with different IDs. So basically, just to simulate a disaster, I just deleted all the instances forcefully like this. But in real world scenario, if you have some, let's say, failure because of runtime exceptions and so on, that will be considered as a downtime or sort of a failure as well. So it will basically automatically start up another identical container instance, and that will be up and running on Kubernetes and so on. So basically, you cannot damage your pods. If you do, it will heal. It will create another identical instance automatically, so that your business activities are still or sort of available to you, or you can there's no downtime involved at all basically. So basically, Kubernetes offers load balancing and self-healing capabilities. And if you do want to delete your deployment properly, you will have to use kubectl delete services. I can delete all my exposed services, and then I can delete all my deployments as well. This is a formal way of saying that I literally don't want these applications to be available anymore. So now you won't have any pods at all. So these are getting terminated. Eventually, they will go away. So it takes a bit of time to do the cleanup and so on. So basically, you can use kubectl create deployment-based approach to deploy your applications. But keep in mind that in case if there's a major disaster and you lost all the machines and so on, and now you need to set up Kubernetes again, and you need to deploy all your applications again, you will have to run all these commands. So one or actually two commands per deployment per application that you want to deploy. And that can be a very time consuming process, because if you have too many applications to deploy, you will have to run lots of commands. So that is where we get to use the other techniques. For example, we have this method number 2 called imperative. In fact, both method 2 and 3, they rely on the YAML file. So YAML is a configuration file where you specify exactly what deployment you want to perform, what's the name of the deployment, what Docker image you want to deploy, what port number you want to use, do you want to restrict, let's say, RAM or CPUs, etc., and so on. Like you can dedicate certain amount of RAM to each container if you want. So you can configure all this stuff in your YAML file. So YAML file wise, we don't have enough time. I'll just quickly give you a brief demo here. So YAML file wise, you have various options. If nothing else, you can choose to use this Visual Studio Code. Make sure you install the extension, Kubernetes extension. And once you install this Kubernetes extension, if you go to your any .yaml file, there you can type in, let's say, deployment. It will automatically show you this IntelliSense sort of option. And when you click on it, it will generate the YAML file for you automatically. So you can name your deployment. You can specify what Docker image you want to deploy, what ports you want to expose. You can even restrict your resources, like what amount of RAM should be available to certain deployment and so on. So basically, you can choose to generate your YAML files like this. Otherwise, you can also choose to use Eclipse with Kubernetes or with the Docker tooling sort of support, or the extensions basically. So these extensions are available for various editors and so on. And you can also choose to generate these from the command prompt as well. It does take a bit of time, so we don't have enough time to discuss that. But I'll just show you my existing YAML files, and I'll show you the benefit that you get with the YAML files. So if I, let's say, show you the contents of this custom folder named restaurant, I have a bunch of YAML files. So I have a couple of YAML files. You can choose to create a single YAML file if you want. And to run these YAML files, you can just use kubectl. And if you use the create-based approach, that is known as the imperative approach, it means you want to perform the deployment just once, and you're never going to modify the deployment in future at all. So for one-time deployment that you're never going to touch again in future, use the kubectl create-based approach and specify the YAML file name. Whereas if you use the declarative approach, method number 3, that's typically the best practice, you get to use kubectl apply. And this will basically let you perform your deployment and also modify the deployment in future. As long as you keep on editing the YAML file, you can redeploy the same thing with a slightly different configuration. So kubectl apply is typically the best practice because it's a imperative in a sense that you're basically just going to give high-level instructions that I need 3 instances of my cluster of my application. So you just give a high-level instruction, whereas in imperative, you're literally uh, telling Kubernetes what baby steps to perform. This is my deployment. Use this command, run it like deploy it like this. Then the same deployment, run this command to make sure that you expose the service. So rather than holding Kubernetes hand, you basically can just give it the high-level picture that this is what I want, and this particular approach, declarative approach, will let you run your scripts with ease and sun. So let me actually show you this kubectl apply based approach here. So here we can use kubectl apply -f and just give it a folder name that can contain any number of YAML files. And if I run this particular command, it will perform all the deployments for us automatically and sun. I can go back to my page. I can refresh it. If it's working, it will eventually show us our site and sun. It does take a bit of time to literally perform the deployment, but eventually it will show us our application here. And I think we are almost out of time as well. So you can use this kubectl apply command and just pass it -f and then give it a folder name. Eventually it will basically perform the deployment for you. And it's repeatable in the sense that as long as you keep on updating the YAML file and you use the same kubectl apply command or argument, it will update your existing deployments and so on. Okay, so basically, overall, we have these 3 main methods. But if you have to pick just one, the most production-oriented way would be to use kubectl apply with your YAML files. Okay, so I think we are out of time, and we have covered all the important concepts at least, but know that it's possible to run commands inside containers as well. So you can use kubectl exec command and then pass it the pod name. That will let you know what files are there in a pod, and so on. For example, if I use kubectl get pods, I can obtain any pod name, like let's say this one, copy to my clipboard, and I can use kubectl exec, and then you can pass it a bunch of arguments like let's say -t, it, and then give it a pod name, and then let's say I want to find out what environment variables are available inside a pod. So these are the environment variables available to my pod. I can get the file list as well with ls and so on. So you are able to run commands inside containers, inside your deployments, uh, and that's all happening in post-deployment scenario, basically. Okay, so basically, if nothing else, just keep in mind that Docker lets us create portable images that contains nothing but just the dependencies and our actual application. And Kubernetes lets us deploy those portable images in such a manner that it should offer load balancing and auto failover, in fact, self-healing sort of capabilities and so on. So there are lots of benefits to using containerization with Docker and so on. Okay, so we do have various courses available on Docker/Kubernetes. For example, we have a course for developers. We also have a course for the administrators as well. So if you guys have any interest, feel free to contact us, and I'll leave the page open here. Thank you very much, guys. It was a pleasure to be here with you for this session.